This week we're going to go over ratios, but today we're going to go over equivalent ratios. What does it mean to be equivalent? Well, equivalent is about the same as if you had 2 glasses of water filled with water and they were different shapes, so you kind of didn't know if they were the same amount of water, if each glass had the equivalent amount of water. In other words, they were the same amount. So you would get 2 measuring cups and you'd pour each glass into a separate measuring cup, and if they both measured up to 2 cups of water, then your glasses would be filled with the equivalent amount of water. They would have the same amount. So that's what we're going to do now with numbers. So a ratio shows the relative size of 2 or more values. So we're going to learn how to find equivalent ratios and to create proportions. So let's go over a few vocabulary words. Ratio is a comparison of 2 quantities by division. Equivalent ratio, ratios that name the same comparison. Then we have proportions, an equation that states that 2 ratios are equivalent. So let's look at how to read ratios. Ratios can be written in several ways. We can do 7 to 5, where we actually use the word 2. We can do 7:5, and then we can use 7 to 5 here. It looks like a fraction, but it's not. It's a ratio. All 3 of these name the same ratio. So these are the 3 different ways you may see ratios written on your test or worksheet in class. Now let's look what it looks like in a picture form. So a ratio is a comparison of 2 quantities by division. In one rectangle, the ratio shaded squares to non-shaded squares are 7 to 5. So you can see here that we have 7 shaded and 5 not shaded. So they're comparing this whole set of squares, and they're comparing the shaded to the non-shaded. Now if we look over here, we have 28 shaded to 20. But if you compare these two, they're the same size. Even though we have 28 to 20 and 7 to 5, doesn't matter. They're still equivalent. They are equivalent to each other. So let's look at what it looks like on paper with numbers. So we're going to find ratios that are equivalent to each given ratio. Multiply or divide the numerator and denominator by the same non-zero number. What does it mean by non-zero number? Well, non-zero means not a zero. So we have to use numbers that are not zeros. So here we take 8 to 16, we multiply the top and the bottom by 2, we get 16 over 32. Here we take 8 to 16, we divide the top and the bottom by 4, and we get 2/4. So if we look over here, 2 ratios that are equivalent to 8 to 16 is 16 to 32 and 2 to 4. These 2 are equivalent to 8 to 16. Then you could also say 8 to 16 and 16 to 32 are equivalent to 2/4. Then you could also say 8 to 16 and 2 to 4 is equivalent to 16 to 32. They're all equivalent. Let's look at another example. We have 32 to 16. We multiply 32 to 16 by 2. We get 16 to 32. We divide 32 to 16 by 8, and we get 4 to 2. So all of these are equivalent to each other. The main thing you have to remember is to multiply the numerator and the denominator by the same number. We cannot do 32 times 2 and 16 times 3. Then they would not be equivalent ratios. We could not take 32 divided by 8 and then 16 divided by 2. You would not get an equivalent ratio. You have to use the same number top and bottom. Ratios that are equivalent are said to be proportional or in proportion. Equivalent ratios are identical when they are written in simplest form. We're going to go over some examples on how to reduce them and show that they're in simplest form and they are still equivalent and proportional. So here we have 2 ratios that we need to simplify. We divide 3 to 27 by 3, we get 1/9. 2 to 18 divided by 2, we get 1 to 9. Well, since 3 to 27 and 2 to 18 are both reduced to simplest form and they come out to be the same ratio, then these 2 are proportional. Okay? We could do the same with 12 to 15 and 27 to 36. We divided both 12 to 15 by 3, get 4 to 5, 27 by 27 to 36, and we divide by 9, and we get 3 to 4. Since these 2 are not the same ratio, these 2 are not proportional. They're not equivalent. They have to be the same. They have to reduce to simplest form to the same numbers. Here's another example that you guys can look at and write down in your notes, where we have 3 to 15 and 9 to 45, and we reduced 3 to 15 by 1 to 5. We reduced 9 to 45 to 1 5. So therefore, these two are equivalent, and they are also proportional because they were reduced to the simplest form, and they reduced the same ratio when they were reduced to the simplest form. Now, 4 to 49 and 16 to 36, those two divided by 7 and 4 did not come up with the same ratio. So therefore, they are not proportional. They are not equivalent. They have to be reduced to the same ratio. Now here we have it in a word problem. We have 4 degrees Celsius, 4 cubic feet of silver has the same mass as 42 cubic feet of water. Okay, so there's our first ratio, 4 to 42. And then at 4 degrees Celsius, would 210 cubic feet of water have the same mass as 20 cubic feet of silver? Well, there's your other comparison. So now you have two ratios. Well, if we divided 4 by 2 and 42 by 2, we reduced it down to its simplest form. And then we took 20 divided by 10 and 210 divided by 10, reduced it down to its simplest form. Well, since they are the same exact ratio, they are equivalent to each other. They are proportional. So 210 cubic feet of water would have the same mass at 4 degrees Celsius as 20 cubic feet of silver. Okay? So here you take what you're comparing and then equal it to the other that you're comparing and then reduce them down to simplest form, and if they come out to the same ratio, they are proportional. Here is a lesson quiz, part 1, that you can do in your notes to show your teacher the next day. The first two, you need to find two ratios that are equivalent to 4 to 15 and two ratios that are equivalent to 8 to 21. And then you need to solve these to see if they are proportional. Reduce them down to their simplest form, and then you can see if they are the same number, same ratio, they are proportional. If not, then you just write not proportional. And here's you a word problem for you to compare. Remember, when you set up a proportion, make sure you set up what is the same, like what is being compared. So you need to read it and see what's being compared, equal it to what's being compared, reduce them both, and if they come to the same ratio, then they are proportional. Now this ends tonight's lesson, and tomorrow you'll have another video on ratios. So be prepared in class to show your teacher your quiz.